Good evening, everybody. This is our Calc 1 Lab Group Delta discussion. We'll be going over how we felt about our lab experience, and I'm here with my wonderful partner and lifetime friend, Brooks Rogers.
Thank you for the introduction, Max. Let's get it started, shall we?
Let's do it.
Beginning of the lab, you, professor, asked us to complete a Desmos assignment for the theorem using a bunch of circles and graphs. How would you say you felt about that, Max?
I felt pretty good. I felt like Desmos takes the concepts that you have to understand completely by the end of the unit, and it breaks it down into such little bite-sized chunks that you don't even realize that you're actually learning it while you're doing it. So it seems not silly, but confusing in a way that it breaks it down to such an extent that you don't even really know what it's talking about.
Mm-hmm.
But I know that it all comes together in the end.
I'd agree with that. This one, I wouldn't say it was challenging. I will say it felt like some of them were trick questions, particularly for the circles covering different portions of the graph,
mm-hmm.
and asking if there were, roots at some point.
Yeah.
I felt like it was kind of leading me to a line of thought, and then would flip the script on me to demonstrate a new concept. And I thought that really helped it stick before learning more in depth about continuity and the IVT by extension.
Yeah, that did seem like a trick question, and it's also it seems like a lot of these things are notation issues. Well, you'll see something that you've seen a million times before,
mm-hmm.
but it wants you to take a theory and apply it in basically the same way, but it's just notated in a way that we're gonna be using it for a calculator on.
Yeah, I agree. I mean, and the only thing with this is that I feel like, well, it taught us what it wanted to well, it got that goal accomplished.
Mm-hmm.
It didn't really hard define the IVT at any
Yeah.
point. Because I recall specifically having to go to the actual lesson plan and looking up a better definition of the IVT and learning through the homework before I could do the homework. So I think that Desmos did what it needed to, but I don't think it was the best in this circumstance, at least from my personal perspective.
And I feel like IVT, I don't know, I guess we haven't actually used it enough, because right now it feels like it's such a limited definition, or it describes something so small that I can't really see it in a larger sense, or even apply it, because I'm well, this is kind of this, and I don't know, I wouldn't be able to look at one function or one or the other function yet and be this is IVT and this isn't IVT.
Yeah, which I think honestly just brings us to the actual lab worksheet itself, where we had to apply the IVT in a more, I don't know, just real life way, I suppose.
Mm-hmm.
Beginning of it just gives us a really brief introduction, has us fill in the blank to define the IVT and when it's applicable, which is suppose that f is a blank, I put continuous function on the closed interval AB, and let n be any number between the output of f of a and the output of f of b, where f of a is not equal to f of b. Then there exists a number c in the open interval AB such that f of c is equal to n. I believe Max had the same thing for continuous and n in both of the blanks.
Oh, I did.
And then just going down the page, not to read the assignment you sent out to us, but just it was helpful to just give a bulleted list of the requirements for the IVT to be met and then used.
Mm-hmm.
Just continuous, that the value is for sure within the given interval, and that I found it interesting that we had to actually state that we were using the IVT within the problem at the conclusion. It wasn't just implied. I thought that was an interesting addition.
And I think I had a hold up here when I use an example of the precipitous CO2 dropping and rising, is that when I think about temperature or CO2 levels, I think about these things as a continuous range of values where it can exist between infinitely many. And then it later used a marble problem, which is you're taking out marbles, which are discrete singular units. And to me, that didn't register as the same type of thing, because you can only take out stuff in whole numbers.
I agree with that. And then speaking more on the marble problem, one thing I thought was interesting about it is that, excuse us, is that
Just go to your room.
You can only take out one marble at a time, and like Max said, that's an integer number increasing or decreasing, as opposed to something that is a little more fluid in nature, like temperature. And then also another interesting part about the marble thing is it's asking if it is possible to have a half bag of marbles at any point from going full to empty, which honestly at first felt like an easy question, but then reading into it, that's only possible assuming the starting number of marbles in your bag is odd. So I don't know if that was the like fully correct answer or if it wasn't, but I put in my answer that the starting number of marbles explicitly had to be even in order for a half bag to be met, and that it was contained on the interval from a full bag to a empty bag.
Which I don't know how that affects like IVT or the concept of IVT, or how that would function differently, like when actually creating the function, or if we're ever going to come back to it. But still trying to think about that more.
For sure. And then, I mean, just speaking on the marble one slightly more, I'm assuming that it was continuous just because nothing in the question would imply that it isn't. So I assumed that just by taking one out at a time until you reach empty, that it would meet the qualifications of continuous, and then therefore also meet the requirements to have the IVT be used on it.
All right. Well, that was, I'd say, all in all, how we fared with the lab. I think personal thoughts wise, I think the only major shortcoming of the lab format as a whole is that it's very hard, as you've probably seen in the past week or so, to like connect all the people in their lab groups virtually. It doesn't seem to work that well, considering that we're only doing this now together because we live next to each other. So hopefully we can come to a technique in the future where we can get our work done without having to like scrounge around for help.
I'd agree with that.
So yeah,
Overall, much love, Professor. Big ups.
bless up,
See you on the other side. It's been real.
stay mathin'.
You know.